I find fractals captivating. Whether they are mathematically derived or created through some natural process. So I decided to build a fractal generator. Twice. Here's how that went. Fractal generators already exist, but for the most part, they're pretty limited. Often you're manipulating a few input sliders or digits, rather than having complete control over the design. I decided to make something a little different. A program where you could create any design you wanted first, and then turn it into a fractal later. The fractals I build will be perfectly self-similar. This means that as you zoom between scales, each design will be a perfect copy of the original. All you need to build this type of fractal is to take the design, like this triangle, scale it down, and paste it at the appropriate locations. Over infinity, this will create a fractal. My first step was building a program where somebody could create whatever base design they wanted. So I remade Microsoft Paint, but worse. The most important functionality was the paint mechanic. When painting, I tracked the user's mouse position, connecting the current X and Y coordinates to the coordinates registered in the last frame. Because computers run so quickly, these coordinates will be very close together, so we can approximate curves. Unfortunately, this leaves cracks whenever an angle change is registered. So we can just draw a circle the same diameter as the thickness of the line every frame. Next, I built a color change mechanic. By tracking the RGB value of the pixel we hover the mouse over, we can map that to a black and white hue strip. Then after the user selects the hue, they can select a size and are good to go. I also threw in a line tool, an eraser, and a background color selector. Finally, after completely recreating a basic art program, I can develop any design I want. Perfect. Let's move on. Now that we can draw an original design, we need seed drawings that the fractal can grow from. The fractal's final design will depend on the location, scale, and rotation of these seed drawings. To create a seed drawing, I made a blank canvas that all the sketches will be copied to. Scaling and rotating this was easy, but I needed to allow the user to drag the seed where they want it. To create a drag mechanic, I need to be able to track when they have their mouse over the canvas. Normally this would be easy, and I could just check if the mouse coordinates fall between the canvas coordinates. But once the canvas rotates, the bounding box of the coordinates no longer matches the bounding box of the canvas, leading to false positives. After hours pondering this question, the answer came to me. I would copy code from Stack Overflow. The solution I used was to calculate the area of the triangles formed between the coordinates of the canvas and the mouse. If this area is equal to the area of the canvas, I know that the mouse is over the canvas. If the area is larger than the canvas area, then the mouse is outside the bounding box. With that problem solved, I could drag around the seed drawing and plant it back onto the original drawing. Next, I built a data structure to store the location of the seed drawings in radial coordinates. I also stored the rotation and scale. Each time they plant a new seed, all of its data is automatically stored. With the seed data, I need to calculate the location, rotation, and scale of the next layer of drawings relative to the previous layer. Fortunately, the relative changes will always be the same, and is in fact the data we stored in the seed table. Here's the system I created. From the last layer of drawings, I take the distance from the origin, or the upper left-hand corner. The distance gets multiplied by the amount we shrink the design. In other words, the relative size. Now I set that vector angle equal to the angle of the last layer, and then I rotate it by the same relative angle from the seed drawing. And now we have a vector that points to the exact same location relative to the last layer as the seed drawing relative to the original canvas. Adding these together gives the vector that points from the origin to this point and is exactly where we want our next layer of drawings. These drawings are set to the last layer's rotation and scale and modified by the relative transformations stored in the seed data. Then by replacing the data from the last layer with the current layer, the process can repeat. Unfortunately, there was a problem. Let me show you this triple branching fractal as an example. Each new drawing of the fractal creates 3 more, until the new layers are almost too small to see. And as this generates, let's look at the data side of things. This white square represents the data stored in the very first layer of the fractal. From that layer, 3 unique drawings are spawned, each with their own position and transformation data. Then each of these spawns new drawings, with their own data packets before being removed. I'm sure you can see where this is going. Any fractal with more than one seed drawing would eventually need infinite storage for all these data packets. The more seed drawings you have, the less layers you will be able to process before hitting some memory limit. Unfortunately, this means I need to cap the drawing number, so I chose about 100,000. Still, after dealing with that data, I had a working fractal generator. First, you can create an initial design, which I finished here, and then you can select the seed locations. Here are some of the designs I made. I also added a back button, so you can make fractals from your fractals. And with that, I had a working fractal generator. I went ahead and built a website for it, FracFu.com, so all of you can mess around with it too. But, as I was halfway through optimizing the code for phones, I happened to stumble across this awesome tutorial on recursive drawing, which I tried to resist. I was 99% of the way through FracFu, but I bet you thought the video was almost over. Well, it's not. I learned a much cooler way to create fractals, and so I started a completely new project. And this is also why FracFu works really well on computers, but not quite as well on phones. After learning about recursive drawing, I was able to create this effect, and while it might not look like much, it manages to create all of these effects without any data structures or pre-programmed calculations. And it responds in real time. Let me show you how it works. First, just like FracFu, an initial drawing is created. In this case, that drawing is this white outline of the canvas. Then, the contents of this canvas are copied to a second canvas. The second canvas is scaled and rotated by some amount as it is drawn back to the original canvas. In my case, I map these to the keyboard and mouse inputs. This process repeats, and when the second canvas copies itself back to the original, it will perfectly overlay the original drawing just one layer deeper. Now what if you change the very first drawing, that boundary around the canvas? One of the cool parts of this technique is that those changes will gradually propagate down the fractal. In this case it's a color, but it could be any transformation. I decided to experiment with adding another canvas to copy to, and the program really started to take shape. Theoretically, you could have as many canvases as you want, but I found that more than 2 becomes frustrating. Even with just 2, some really interesting patterns emerge. I decided to go ahead and make a new generator. I chose our favorite pattern for the initial design, and FracFlora was born. color changing really adds a lot of interesting features to the program. You can clearly see the color propagation, as well as its slowing down the further into the fractal it gets, and the static it creates if enough layers are revealed are a perfect demonstration of chaos theory. If you want to play with FracFlora, I went ahead and linked it below. I did finish the optimization this time, so it should work really well on everything. Also, I designed some shirts with FracFu. I'll go ahead and link it in the description in case any of you guys want to check it out. And that's it for my fractal experiments. I will say if anyone wants to use this techniques in their own project, go ahead. And if anyone wants to use this same technique for copying meshes, this would make a really cool experimental 3D fractal generator. At least the way that FracFu does it. If you want to see more of my projects, stick around the channel. Adios.